Recent research reveals that the Atlantic Meridional Overturning Circulation AMOC, a vital ocean current system, is slowing down. This weakening is expected to reduce the extent of future Arctic temperature increases. Without this shift, temperatures in the Arctic could surge by up to 10 degrees Celsius by the end of the century. However, the weakened AMOC could limit this rise to about 8 degrees Celsius. While this deceleration of warming offers a slight reprieve, it doesn't eliminate the broader climate challenges, including impacts on ecosystems, shifts in tropical rain patterns, and global disruptions. The AMOC plays a critical role in distributing heat around the globe, and its reduction could help slow the warming in the Arctic by limiting the amount of heat transported to the region. Scientists found that while the slowing of this ocean current reduces Arctic warming slightly, it still leads to significant disruptions. For instance, a weakening of the AMOC may shift the Intertropical Convergence Zone ITCZ, a key tropical rain belt, southward. This shift could result in more frequent droughts in areas dependent on this rainfall, affecting agriculture and water supplies. Despite the potential for the AMOC to slow Arctic warming, it doesn't mitigate other effects of climate change in the region. The Arctic ecosystem remains highly vulnerable, particularly with the continued loss of sea ice. Melting sea ice poses serious threats to species like polar bears, which depend on the ice for hunting. Moreover, as the ice melts, darker waters are exposed, absorbing more sunlight and further accelerating warming through a process known as the albedo effect. One common misconception is that melting sea ice directly contributes to rising sea levels. In reality, sea ice melting has a minimal effect on sea levels, much like how a glass of water doesn't overflow when ice cubes melt. Instead, rising sea levels are primarily driven by the melting of land ice, such as glaciers, and thermal expansion of water as it warms. The study's authors used climate model simulations to compare two scenarios, one in which the AMOC slows due to rising greenhouse gases, and another where its strength remains constant. These models show that even with a reduction in Arctic warming, the overall impact on ecosystems and global weather patterns remains significant. While the AMOC slowdown provides temporary relief, it does not change the fact that small shifts in ocean circulation can have ripple effects across the planet. In conclusion, while the AMOC slowdown may offer a temporary moderation of Arctic warming, the broader consequences of climate change are still severe. The future of the Arctic and the global climate will depend on how quickly we act to mitigate climate change.